KY Pipe's scenario management feature is innovative and unique in that it does not rely on the same parent-child type relationship utilized by other software. In our own testing during development, we found too many limitations associated with that approach. So instead, we utilize individual model copies with methods of visualization and data transfer between the various copies. To get started, we have loaded the modeling file called baseline.p2k, and we are in the Scenario Manager tab. Here we see that this file has been designated as our main scenario. Normally, users will start with an original scenario, like this one, then create one or more copies of their original modeling file, using different names that contain the alterations they wish to test. The scenario management feature then allows users to compare the effect of these potential changes and to copy desired changes between the different .p2k files. Throughout this video, we will refer to these individual .p2k files as modeling files, scenarios, or systems. Note that the scenario management feature doesn't save user-made changes to any kind of external file that is unique to this feature. All changes are saved to the individual modeling files. While we are in the Scenario Management tab, we can use all the functions of this feature, including viewing, analyzing, and editing both the main scenario, sometimes referred to as the current scenario, and up to 3 comparison scenarios, so 4 scenarios can be worked with at once. However, any changes made to the model using the other tabs will only apply to the model whose name is displayed in the main scenario field. Also, edits made in the map area only apply to the main scenario, more on this later. So, within the tab, 2 scenarios are currently listed: Baseline and Southeast Extension. These are displayed in the map view with an XY offset to enhance their viewability, since otherwise many of their elements would overlap. We could turn off the comparison scenario by unchecking this box. We now see the comparison scenario is gone. But for now, we'll leave it checked. When we add the comparison scenario, we are prompted to save the current scenario. The similarities and differences between these two models are color-coded according to this key. By default, any pipe shown in blue and any nodes shown with a pale yellow interior are part of the main scenario. Conversely, pipes and nodes shown all in gray are part of the comparison scenario. We can see from our key that the blue pipes and pale yellow nodes from the main scenario are matched with the gray pipes and gray nodes of the comparison system. The word matched means that nodes are in the same physical XY location, at least within a certain margin of error, and must be of the same type. So a pump can't match with a tank, for example. Pipes are matched using a similar method. That is, if the end nodes of a pipe in the main system line up with the end nodes of a pipe in the comparison system, we describe these as a match even if the pipe doesn't follow the same path between the 2 end nodes. On this subject, sometimes it looks like 2 pipes should be matched, but they aren't. The reason is that junctions can't match with intermediate nodes. These 2 pipes look like they should be matched, but these are intermediate nodes, and these are junction nodes, which is why the pipes are not matched even though it looks like they should be at first glance. However, matching different elements isn't just based on XY location and node type. For these pipes and nodes shown in blue and yellow, not only must their physical locations be the same, and node types be the same, but all the input parameters must also be identical, except for their names. So, these nodes have the same elevation and demand, and these pipes have the same roughness and diameter, etc. To summarize, These two color codings are used to display elements, that is to say, nodes or pipes, which are fully matched in location, type, and their input parameters, but their names can be different. However, this leaves us with the question of how to display nodes and pipes which are either unmatched between the two scenarios, or are matched by location and type but have parameter input differences. Here's an example of nodes which are present in both scenarios, but which have parameter input differences. These nodes with a green interior and exterior are present in the main scenario. They are also present at the same location in the comparison scenario and are of the same type. But let's look at this further. If I click on this node from the main scenario, we see that both the node and its match from within the comparison scenario are automatically selected, and their data appears within the Node Info window. That happens because I've checked this box under the Appearance tab. Note that auto-selecting comparison nodes and pipes only works while we are in layout mode, not in group mode. While these nodes are matched in both location and type, we see a parameter difference in the demand field and also in the elevation field. That's why the icons for these nodes are both green. That is to say, they are a match, but with at least one input parameter difference. Last, we have nodes that are completely unmatched by their XY location and/or type, regardless of their input parameters. Nodes and pipes without matches have one of two different color codings. Those that are present only in the main scenario are colored aqua and light blue. Those that are present only in the comparison scenario are colored red. Here I want to bring up a question that has arisen. That is, can we create a match by giving a node or a pipe the same name in both the main system and the comparison system? But now we know the answer. That is, giving two different nodes or pipes the same name does not produce a match on its own. It's actually the opposite. Names are not considered when evaluating parameter input differences. In addition to using the Node Info window to see the similarities and differences between paired nodes or pipes, we can also see the same data using labels in the map area, just as we could if we were only working with a single model outside of the scenario management feature. For instance, if we turn on labels for demand, and we know from looking at the Node Info window earlier that the demand is different for at least one of these blue-colored nodes in the main scenario versus the matched node in the comparison scenario, those differences are displayed in the map area. So, labels work essentially the same way whether we are working with a single model or working with two models inside the scenario manager. Once we have our scenarios built, the next step is to compare their outputs so we can determine which of the differences we want to keep and possibly copy these changes to other comparison scenarios, since we can work with up to 4 scenarios at once. But for now, we only have 2 scenarios, the main and the comparison, which are the limit of what can be displayed in the map area so that it doesn't become too crowded. Both of these scenarios can be analyzed and the results displayed simultaneously using labels within the map area, as well as shown within the Node and Pipe Info windows. To do this, we'll click on the Appearance tab, and then click on the Analyze Both button. This gives us a drop-down, which allows us to both analyze and to globally turn on labels for nodes, pipes, both, or neither. For now, we'll choose Analyze and Label Results at All Nodes. Before we proceed, we are asked if we want to save any changes we may have made to the main scenario. This is obligatory. The save is necessary so that the software can switch between the 2 open model files. Therefore, make sure that you want to keep any changes you've made to the main scenario at this point, or decide that you want to discard them. We'll click Yes. and now we see our labeled pressure results. As you would expect, based on the differences between the two scenarios, the pressures are slightly different at most points in the system. We can also see these same results in the Node Info window if we click on the A button, which displays values for result A, which, for nodes, defaults to displaying pressure values. However, the map area, which we often refer to as the map view when in the Scenario Management tab, isn't the only way to see and edit scenario input and output data. Instead, we can open the Table Manager, sometimes called the Table View. We open the Table View by clicking on this button, and we are asked if we want to choose from these pre-populated filters. So we'll choose All Pipes and Nodes. This again requires us to save the main scenario. Whenever you move from the map view to the table view, you will be prompted to save the main scenario. Upon opening the table view, we see the main scenario on the left and the comparison scenario on the right. We could load up to 4 different scenarios within the table view, and if we did, we could scroll to the right to see the additional scenarios. The table view shows general modeled settings and other information at the top, then change data for pipes and nodes, as well as demand patterns, after which are the data input and output sections for pipes and then nodes as we scroll down. When the Table Manager is initially loaded, we can see the node and pipe input data, but the results will not be populated. Therefore, we will go to the Refresh Analyze drop-down and click on Analyze and Refresh to update the results. Now we can see both our input and output values. Similar to the color coding in the map view, a green color denotes input values that match between these two modeling files, whereas gray is used for matches in output data, and red denotes differences in either the input or output values. Here we see pipes that are present in the comparison scenario, but not present in the main scenario. These also show up in red font. To exit the Table Manager, we click this X in the upper right-hand corner, and we are asked if we want to save our changes, to which we'll say yes. As we saw earlier, when we are in the Scenario Management tab, we see these 3 sub-tabs. Within the Scenarios tab, as we saw, we can display the comparison scenario, or choose not to display it by checking or unchecking this box. In this case, we have loaded a comparison scenario called Southeast Extension. However, I could choose a different file using this drop-down, which gives me the option to load any .p2k file within the same folder as the main scenario, although it does use a predictive routine to select the most likely model names from among the available files, and thus may not display all files present in that folder. If the comparison scenario I want to load isn't in the same folder as the main scenario, or doesn't appear in the list, I can browse to it using this button. We could also add up to 2 other scenarios to the Scenario Manager using these drop-downs in browsing to new files. But these additional 2 comparison scenarios are only accessible in the Table View, not in the Map View. Next is the Appearance tab. This is where we will spend most of our modeling time while in the Scenario Manager. Like the Scenarios tab, this tab also has the option to display or hide the comparison scenario. And it also displays the button that launches the Table Scenario Manager, so we don't have to switch tabs if we want to see our models in Table View. The Auto Select Comparison Pipes Nodes checkbox lets us choose whether we want to select a matching node from the comparison system when we select a node in the main system. Selecting a node or a pipe causes its input data to appear in the node or pipe info window, and so long as we have this box checked, we will also see the data for any matching node or pipe within the info window. If we uncheck the box and then click on a pipe, we see the data for that pipe in the main scenario, but not for its match. This submenu lets us choose whether labels are displayed only for one of the scenarios or for both. Let's turn on some labels to demonstrate. Here we are showing node names. We can turn them on for just the main scenario, just the comparison scenario, or for both. If we click on the Swap Scenarios button, as it implies, the main scenario and the comparison scenario will switch. This is useful because it allows us to edit the comparison scenario, since only the main scenario is editable. The offset controls the distance between the display of the two scenarios. This field shows the linear distance between the projection of the two models in map units, which are feet or meters, depending on whether you are using English or metric units. The main scenario is always aligned with the background, so the comparison scenario is the one that is offset. Both the distance and the direction of the offset can be altered manually for the best appearance for each model. You'll need to click on the refresh button after making a change. Alternately, a default offset amount may be applied by checking this box. When the auto check box is checked, the user-defined offset distance still appears but is not used. This set of radio buttons controls the offset direction regarding left and right and up and down, which we can see by clicking through the options. When you save the P2K modeling file of the main system, you also save changes made to any of these menus underneath the Scenario Manager tab. So if you set the offset, distance, and direction manually, your settings will be applied the next time you open the .p2k file for the main system. These next three checkboxes control information displayed by the key. First, we can turn the key off and turn it back on. Next, we can decide if we want to emphasize nodes and pipes that are unmatched between the two scenarios. And likewise, we can decide if we want to emphasize the differences between the two scenarios. Usually, it's best to leave these boxes checked. This button accesses the Colors and Sizes menu, which controls the color coding for differences and matches between the two scenarios. We can click on the Map button here in the main menu to exit the Colors and Sizes menu. Next is the Editing tab. Here we see a Matching Tolerance submenu. This is used to determine the maximum distance within which two model elements are considered to be a match by the program. Again, the units are either feet or meters. We can set this distance manually, or we can check this box and a default value will be used. If we reset the user tolerance manually, we will need to click on the refresh button to apply the change. This tolerance value is necessary because, as nodes are added manually to the different modeling files and edited, their positions may not precisely match that of their corresponding node in a different scenario. This allows nodes some location difference while still retaining their status as a match. As an example, these two nodes are matches. If I unlock the model for editing, then drag this junction node a small distance away, and then click the refresh button, we can see that it's now labeled as part of the main system without a match. The connecting pipe is also no longer a match. If I drag the junction back to its approximate original location, and then click the refresh button, we can see that it again lies within our user-defined tolerance and is back to being a match. The alternative would be to explicitly copy and paste the XY locations of all nodes that were intended to match, but that's usually not necessary and can become repetitive, thus this feature can save modelers time. There is a fix names function. It only works on nodes and pipes that are geographical matches. It standardizes their names by copying and pasting the names of the pipes and nodes in the main scenario to their geographical matches in the comparison scenario. This is not a requirement. Names don't have to match. They can be different, and that is sometimes useful. However, if you're going to use the table view, it's very important to understand that nodes and pipes shown in the table view are arranged, that is to say, sorted, by their names, not by geographical location. So, if you want to be able to compare the input and output values of pipes and nodes in the table view between the main scenario and the comparison scenario, line by line, we must standardize their names. If you're happy with the names that are present in the main scenario, you can automatically copy and paste them to their geographical matches within the comparison scenario using this feature. If you prefer the names in the comparison scenario instead, of course you can swap the scenarios and then use the Fix Names button. Lastly, there is a push function. It's somewhat similar to the Fix Names function in that it copies and pastes from the main scenario to the comparison scenario, but it transfers whole elements, that is to say, nodes and/or pipes, instead of just node names. We will demonstrate this later in the video, along with other methods of sharing data. Settings to be aware of, which don't appear in the Scenario Manager tab, are the colors used for the model and the various matching conditions, and the key location. The pipe and node colors are editable and can become important depending on your preferred background. Right now we are using a light MapQuest background, and the various colors show up readily. However, if I wanted to switch to a Google Satellite Internet map, for example, the default colors are not as ideal. We'll go to the Colors menu and choose lighter colors, which should be easier to see against this darker background. These are the settings for the main scenario, and we'll choose a new pipe color and interior node color, a primary yellow for both. For the comparison pipe color, we'll choose white. These show up better, and you can adjust them as needed. If the color coding key needs to be moved, this is accomplished in the Appearance tab under either the Pipe Emphasis or Node Contours menu. Here we see the key move as we select from among these options. For a practical look at the Scenario Manager, we'll start with the model we've already been looking at as the main scenario and see some ways we can work with comparison scenarios. This model is of a small town that purchases water from a nearby water system through a connection, represented here by a pressure supply node. Our first task is to evaluate a scenario where we are adding a subdivision and a second overhead storage tank to our existing system. We've seen some of this already, but let's just walk through how these first two scenarios were created. Normally, in the model building process, we would load our baseline scenario, make the necessary changes by adding the pipeline extension and the tank. Then we would go to the File menu and use the Save As command to save a copy of the model, leaving the original system unchanged. Since we've already seen these two scenarios, we won't go through that process. Instead, we'll just check this box to display the second model now. And we'll analyze both scenarios. Now we can see the differences in pressure between the two models. We could also use the table view to see those differences, but for now, we'll just use the labels. We see the comparison scenario generally has higher pressures at the nodes because the newly added overhead storage tank adds pressure to the system. Next, let's say we want to evaluate another comparison scenario, that is to say, a third scenario overall, and in this third scenario, we want to know what happens when the extension and the new tank have both been added, but the supply connection from the larger water utility is not available, and thus the only supply to the town is from the two overhead tanks in the model. For this example, I'm going to use edit options outside of the scenario manager. First, let's stop displaying the comparison scenario. The next step is to insert a valve into the main scenario, which can be used to isolate the supply. We'll enter a negligible CV and leave the valve open. After all, the valve is open in the main scenario. We'll save this model. Now we can use the node copy-paste function in the node info window. First, we select the valve, click Copy, open the first comparison scenario, and paste it over the existing junction node. Now we'll use Save As to create a second comparison scenario, or the third scenario overall, called Southeast Extension Disconnected.p2k. Within this new file, we'll close the valve, but only within this scenario. Now we'll load baseline.p2k as the main scenario, Southeast Extension.p2k as the first comparison scenario, and Southeast Extension Disconnected.p2k as the second comparison scenario, or third scenario overall. If we want to see the output from all three, we can go to the table view, then use this drop-down to hit Analyze and Refresh. Now we can scroll to see the differences in flow and velocity in the pipes, and the differences in pressure at the nodes between the three scenarios. We have seen how to copy and paste a node manually between different scenarios. But with the push feature, in versions where it is available, copying and pasting model elements from the main scenario to a comparison scenario will be automated. Here's what it will look like. Let's say the new tank in the first comparison scenario has been funded and built ahead of time, so we want to have that tank present in our main scenario as well as our two comparison scenarios. The first thing to do is to swap the scenarios. So Southeast Extension.p2k is now the main scenario. Next, we'll go to the Edit tab, where we want to push this tank from Southeast Extension.p2k to Baseline.p2k. Performing a push moves the selected pipes and any connecting nodes. So if you want to push a certain node, be certain that one of the connecting pipes is also selected for the push. When we click on Step 1, we are given instructions on how to perform the push. The instructions tell us that we need to go to the Map tab and enter Group Mode so we can select the pipes and nodes we want to push. We could select the nodes and pipes by clicking on them individually to add them to a group, or by drawing a group polygon or a group box. Also, before we add pipes or nodes to our group, if there are pre-existing selections, we can use this button to clear them. Then, for this example, we'll just click on the nodes and pipes we want. Now we can skip Step 2 and go to Step 3, which is to do the push. But before we click the button, we need to decide if we want to save any changes we may have made to the main scenario up to this point. There are none, so we don't have to worry about it for this example, but it's important to be certain before we perform the push, since this feature opens both models in sequence and any unsaved changes will be lost. So, clicking on the button, we can see that there's a warning message, but as we discussed, we can just say yes. Next, we'll see a preview of the results of the push. And we'll be asked to verify that these are okay. If they don't look right, we don't have to retain them, which would mean clicking on the Step 4 button to go back without saving the changes. But in this example, the results look fine, so we'll click the button for Step 4 and choose the option to save changes to the comparison system and go back to the main system. Now we see that the tank has been duplicated within the baseline scenario, and we can swap scenarios again if we need to keep editing. So there's an example of using the push feature versus doing a direct edit. We selected our single pipe and single node manually, but if we wanted to push this entire subdivision, it would probably be best to draw a group polygon instead. A final word of caution about the push feature. We have showed you how to push an unmatched node and pipe from the main scenario to the first comparison scenario. But what if there was a matching pipe with a parameter difference that needed to be pushed? At this point, you would need to select the pipe and its match, along with the nodes on either end of the pipe, in both the main scenario and the comparison scenario to complete the process. Next, we'll discuss demand patterns and change patterns. We've found that it's best to set these up using the normal model editing process in just one of your scenarios first. Then you can share them between scenarios utilizing the file save and load function found in their respective submenus. For example, we'll create a change pattern for the valve by turning off the comparison, then entering the data. We can access the node changes table for just this node by clicking on this button, or we could go to the Scenarios tab and click on the Node Changes button, where we can see the changes for all nodes in the model. Either way will work. Here we'll create some changes. For case 1, we'll leave the valve open. For case 2, we'll shut it halfway. And for case 3, we'll close it completely. We can then save the file that contains these 3 changes externally. Let's call it Supply System Valve Changes. Don't forget to save and exit, or the changes won't be applied within the current model. We'll also need to save the current model before we close it. Now we'll use the File menu to open the first comparison scenario, which is southeastextension.p2k. Just in normal mode, not in the Scenario Manager. Go to the Node Changes menu and load the change file. In the same way, we can export and load demand patterns. In the current model, we'll create a change pattern for residential demands, where they are normal in case 1, 50% of normal in case 2, and 25% above normal in case 3. We can then save this demand pattern externally then save and exit by clicking the OK button, save the model, reload the baseline scenario, and load the saved demand pattern into the current model from the external file. Now let's look at the Table Manager, also often referred to as the table view. We don't need to analyze before opening the table view, because closing the map view in order to open the table view clears our analytical results. One important note about the table view: if you're going to click away from it, it needs to be resized to be smaller. The reason is that you may not be able to reopen it once it's minimized to the taskbar. Instead, you'll have to right-click to close it, then start over. But once within the Table Manager, we can analyze both models and refresh the results. The menus here give us the option to control which model inputs and outputs are displayed. Under the Sections drop-down, we can see that each item in the drop-down corresponds to a block of data in the table. Many of the data types are checked, but often there are additional data types we aren't displaying, probably because we don't need to see them. As an example, for pipes, the most commonly used data items are already checked. This includes length, diameter, and roughness for the inputs, as well as flow and velocity for the outputs. These were selected because we almost always want to see them, but we have other options as shown in the menu. As stated, though, we often leave these turned off, lest the table become so wide that we can't compare two different scenarios side by side. Similarly, for junctions, we are displaying name, elevation, demand, pressure, and flow, but we have further options if we need them. We can also create additional sections. Say if we want to see a section with all of our pumps or all of our tanks, or a mix of the two. We don't have any pumps in this model, but let's create a block of data for our supply nodes. There are 4 different steps we need to complete in order to create and view a new section. And if we skip any one of the steps, the section won't appear. Step 1 is to create the new section, including giving it a name and populating it with node types. We'll use the Node 1 space, overwriting it with our selections. For the name, let's call this Supply Nodes. Let's check the boxes for tanks and for pressure supplies. That's step 1. For step 2, we need to decide what types of input and output data we want to see. Let's choose node type, name, elevation, and result A. We said earlier that result A defaults to pressure at nodes, but these defaults can be changed using the Results Selector menu if we need to. We'll leave these values as their default type. That's step 2. For step 3, we need to click on Show Section. And for step 4, we need to refresh the table. If you've made a change, but the change hasn't showed up, you should always try to refresh the table first. Next, the Scenarios tab shows us where we can load additional comparison files, and this section of the menu controls how the differences are displayed. Under the Edit tab, we have options for copying and pasting. This first option is used when we wish to make model edits within the table view, as these edits can be pasted after they are copied. The second option is used when we want to transfer the contents of the table to an external application. We could also enter full edit mode. The full edit mode is quite powerful, but it's not completely unlimited. Full functionality is only available when we use the main graphic user interface. A rule of thumb is that you can edit anything you can see that isn't in gray font. So you can change the length, diameter, or roughness of a pipe, or you could change the elevation of a node, but you can't change the node name or the pipe name. Further, you can't add or delete pipes or nodes. That's because these elements have an XY characteristic and connectivity characteristics that can only be added within the graphic user interface, not within a spreadsheet. Edit options include cut, copy, and paste. There's also a reconcile rows command. This command normalizes data from the main scenario to any loaded comparison scenario, element by element. So, for example, pipe P13 has a different length in the first comparison scenario when compared to the main scenario. Using the reconcile rows command would automatically copy and paste the input values from pipe P13 in the main scenario to its match in all displayed comparison scenarios. So, for now, we only have one comparison scenario, but we could load up to 3 comparison scenarios, and, if we did, reconcile rows would affect all 3 simultaneously. Here's how it looks. When we're finished editing, we can save and exit the full edit mode. Or if we don't like the changes we made, we can exit without saving changes. Now we've left full edit mode, but we're still in the table view. To finish discussing the drop-down menus, next we have the Refresh Analyze menu, which we've already seen. Within the Export menu, we can export everything we see to Microsoft Excel, to a tabbed text file, or we can add part or all of what we see in the table view to the presentation generator.